machine. One apple, take one.
We are here to get observations from the North Atlantic Ocean, and particularly the subpolar gyre. The Atlantic water is flowing northward with the North Atlantic current towards Europe. And this warm water circulates around the subpolar gyre, past Iceland and Greenland, and on its way south again. The subpolar gyre is an area where strong cooling occurs of Atlantic water masses. We are collecting observations across the whole gyre to understand the exact process that's involved with this water mass transformation.
Ja, de release oké en hij komt wel duidelijk omhoog.
Oké, ik ga er naar uitkijken.
There, right in front. These ocean observations are used to understand our climate and climate change and the role of the ocean in the processes that determine the climate. In order to really see how changes in the ocean affect climate and vice versa, how climate change may affect ocean currents, we really need long time series. And these time series are collected by these mooring arrays that are installed on different locations in the Atlantic Ocean. The moorings are about 2.5 kilometers to 1 kilometer long, held down at the bottom with a heavy weight. And then it's a long cable with, at several designated depths, we have instrumentation that's measuring temperature, salinity and velocities. So they're typically out for 1 year. And then the next year we come back and we collect the moorings and collect the instruments. The instruments we retrieve the data from, and we service the instruments, replace the batteries and so on, and make sure that they can function again for another year. And then we deploy them again on the same location to get another year of time series.
Check, force field. Eerst gaat het gewoon met de bollen weg.
The moorings, they are fixed on one location and they measure at selected depths. But in addition to that, we also collect so-called CTD data, that stands for connectivity, temperature and depth. And we collect these data with an instrument that's lowered from the ship. So we get a vertical profile of temperature, salinity and as well as velocity.
So we're standing on the CTD rosette. The actual CTD are the sensors inside here. They're in a big pressure housing to take the pressure down at 3 kilometers or more. There's a pump here that pumps water passing the sensors, and then it measures all the variables. So around the sensors we have these sample bottles. They're called Niskin bottles. And at different depths we take samples to calibrate the sensors. So when we get to a depth where we want to sample, we stop the frame and we wait for a minute to let the water settle. Then we close one of these bottles, and then we have 12 liters of water from that depth. And from that volume of water, we take samples for calibration, and we take samples for oxygen and salinity.
So the CTD measurements, they complement the mooring data because with the CTD we get high resolution data in the vertical from one location, whereas the mooring array, they give us time series at one location.
I'm deploying Rafos floats. They're density neutral floats, so that means that as opposed to drifters that sit on top of the water, Rafos floats match the density of a water mass and they sink deep beneath the ocean and then they follow deep ocean currents. These ones will stay under for 2 years, tracking where they go, and then after 2 years they'll come up to the surface and upload all of their information to satellite. Nope.
40 floats were deployed last year. We're doing about 47 this year, and then some more next year, and they all have 2-year deployments. And that's about the time that we think the circulation needs to get around the Mid-Atlantic ridge and then around to the Labrador Sea. And we don't know much about the deep currents. We know a lot about the surface currents because you can measure them with the satellites, but we hope to get more information about the deep currents.
Godspeed, my little floats. May you drift far and deep beneath the surface of the ocean.
No? Good stuff, guys. Thank you.
This is the CTD profiler, also called het gele karretje. It's pressed onto the cable with a wheel, with a spring, and every day it makes a profile along the cable. There's a little CTD on it, so it measures temperature, salinity, and depth again. And we put it in this position because we want to see deep convection, so deep mixing, which happens here during very cold winters. This winter has been really cold, so I really want to see this data. I was looking for deep mixed layers, and deep is about 1 kilometer. The first year we got 400 meters, the second year we got 400 meters. Not until the 5th year that we finally got the deep mixed layers. But now they seem to be even deeper, maybe even 1400, so that's really nice. Dit is allemaal mixen?
Ja, ziet er goed uit. So we measured this deep convection, and at the same time we are measuring in the boundary currents with these mooring arrays that have been installed in 2014. So now we have a very good time series on different locations, and we can see how this deep convection influences the exchange between the boundary currents and the interior. This is it. This is as far west as we get. Yeah, it's nice. There's Greenland, there's ice, but we can't go further now. So, final station. The cruise has been very successful. We retrieved all our moorings and we've got very good data back. And now we will start with analyzing these data and try to understand better what is happening in this area of the world.
Signing off.
Signing off. Delivered.